Section 6.3, Homework Problem 17. Use the standard division algorithm, which is the long division process, or we call the common method, and to determine the decimal representation of 1/9 to the 10,000th place. And number 2, part B, we need to interpret the steps in terms of money. So this is an example. I divided 2 by 7. So imagine if we have $2 and divided equally among 7 people. So we first do the standard algorithm, which is long division. So when we set it up, and then 7 is the money we're going to divide. Sorry, $2 is the money we divide by, and the 7 is how many people we have. And so first of all, of course, if we 2 means 2 ones. So if we have 2 $1 bills, that's not enough for everybody to get a $1 and a dollar bill. So that's why we're going to put a 0 up here, that lining up with 2, indicating that everybody will get $0 $1 bills, 0 ones. But we are going to add another 0, which is the how many dimes? The tenths. So we have $1 can be exchanged for 10 dimes. So $2 can be exchanged for 20. So when we do division, we only put the decimal point up, place the decimal point above the line, lining up with the place decimal point in the number. But when we do division process, we do long division process, we don't really consider decimal point. We just think of this as 20. Again, because the place value of this 0 means the tenths. In terms of money, that's the dimes. So you're thinking of this as 20 tenths or 20 dimes, because $1 equals 10 dimes, $2 equal 20 dimes. So here, imagine you have 20 dimes split among 7 people. So that would give everybody 2 dimes. And every dime, I'm sorry, 2 dimes. So because everybody gets 2 dimes, so 7 people times 2 dimes, that gives us 14. So here 14 comes from 7 times 2, 14 dimes. And subtract 14 from 20 gives us 6 times left. And if we want to continue to split the dimes, again, 6, if we only have used dimes, that's not enough for 7 people. But we can add another 0, which means pennies, to represent, because the place value is 100 or 1 penny. So 6 times 1 dime is 10 pennies, 6 times 60 pennies. So again, this means 60 pennies. And divide by 7, so everybody can get 8 pennies. And that's a total of 7 times 8, which is 56 pennies. And we had 60 giving out 56 pennies, so we're left with 4 pennies. And normally, in real life, we can stop here, but we want to continue to do one more step, adding another 0 and bring it down. So remember, the process is always divide. Say 20 divide. How did we get this 2 here? It's 20 divided by 7. So roughly you get a 2, but with the remainder, which is to be calculated. And so in order to calculate the remainder, we have to do multiplication. So this is the division, and this part 14 here is the multiplication, which we did 2 times 7, or 7 times 2, 14, 2 sevens. And then we did a subtraction here. So that's multiplication, that's subtraction. And this 0, we brought it down. So does McDonald's sell burgers? And to use this to help you remember the 4 steps that we have to do in the standard algorithm. And after that, after you bring down, you have to repeat the process. So we did another division to figure out 8, 60 dimes divided by 7 people, and we can get 8. And with the remainder, which is to be calculated, we have to do multiplication again. So if 7 people, we give everybody 8 dimes. That's a total of 56 dimes. And again, we got to do subtraction again to get 4 dimes left. and then we add another 0 and we bring down. B here means bring down. So we can keep doing this. So if because in this case, they want us to round it to the 10,000th place. So we have to, this is the 10th, 100th, and thousandths and 10,000th place. So we have to do at least four rounds. So we here you can see I'm just going to use my solution here to explain the rest of it. So 40 and divide by 7, that gives us at most 5. And then we do multiplication, 5 sevens gives us 35, and do subtraction to get 5. So 40 minus 35 is 5. And then we bring down another 0. So this 0 was brought down. We can keep adding zeros. Now we can see 50 divided by 7 at most 7. And then 7 sevens are 49, and with the remainder 1. So that's already. And notice if you need to know whether we should, I guess you can stop here because we reached the 10,000th place. And if you want to do one more and to decide whether we need to run it up or run it down, you can add another one. You can notice that 7 only goes into 10 one time. So you have to just keep 7. You cannot run it up because 1 is less than 5. So it's 0.2857. So that's the standard algorithm here. Okay, next in part B, we want to use the money to explain. So pretty much like I explained in the process. So we divide $2 among 7 people. And first step, we ask, again, because there are only 2 $1 bills, that's not enough, which is smaller than number of people 7. We cannot give each person $1. So we trade each dollar for 10 dimes. Now we have 20 dimes, and we now give each of the 7 people 2 dimes. And using so a total of 14 dimes, because if we give everybody 2 dimes, 7 people will cost us 14 dimes. Okay, and leaving 6 dimes left after subtraction, we know we have 6 dimes, and we continue to trade each dime for 10 pennies, and then we have 60 pennies, and each person can get 8 pennies. That's a total of 78 pennies, which comes from 7 people times 8 pennies each person, 56. And then we figure out we have 4 pennies left. So therefore, each person will get 28 cents, or you can say $0.28 with 4 pennies left. For the rest of the steps, we cannot use the money to explain, so you can just stop right here. Because the smallest coin values we have is penny. So we don't have anything less than penny. So you don't have to explain the rest of it using money.